students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss linear congruence. This will be linear congruence part 1. And some of you, maybe when you start viewing this video, you might ask why is it that part 2, linear congruence part 2, has so many views more than linear congruence part 1? Especially when I finish this video and upload it, probably today or tomorrow. If you view the video recently, maybe tomorrow or by next tomorrow, you might notice that, hey, part 2 has more views than part 1. So this is a redo. This is a redo of part 1, linear congruence part 1. And why am I redoing it? I noticed that linear congruence part 1 right now, it has more than 45,000 views. It has about 120 likes and 35 dislikes. And and then linear congruence part 2 has more than 10,000 views. It has 57 likes and zero dislikes. So I was like, what's the problem? And then I reviewed the comments on linear congruence part 1. I reviewed the comments, and some students were asking questions, and these are questions I have already addressed. I've already addressed in prior videos. So this video on modular arithmetic and algorithms, it is the playlist. So let me say this now, please. Okay, before you continue with this video, linear congruence part 1, please view the videos in the playlist in order. Now, how do you get the videos in the playlist? You can get it from my website, any of my 2 main websites, samuelchukwuemeka.com or chukwuemekasamuel.com. Any of them. You can go to that website, you click on mathematics, you click on discrete math, then in the video section, you click on modular arithmetic and algorithms. It's the video playlist. Alternatively, you can go to this website, www.modular-arithmetic.appspot.com. This website contains everything about modular arithmetic and algorithms. It contains the links to all the videos. I'm working on the notes right now, and it even contains the calculators to everything I have taught so far. All the topics I've taught so far in this topic: modulo, GCD, LCM, Bezo's coefficients, modular inverse, linear congruence, modular exponentiation, and more. So it contains calculators of all those topics. Is in this website. So please, specifically you need to view that modular inverse video. Modular inverse part 1 and part 2. It's required that you have viewed those 2 videos prior to viewing this one. Why? Because some of the answers we got from that video, I will be using it here. To save time, I will not go back to do it. And that was the issue that I noticed, because some of the questions in the comments were asking me, how did you get this? How did you get that? It was because those students asking those questions didn't view prior videos. So I had to say, please view the videos in order. Okay, please view it in order so that I don't come and start doing what I've done before. Okay, so, you know, if I notice, hey, ordinarily I wouldn't be deterred by it, you know, students when they post likes and dislikes. Ordinarily I wouldn't be deterred by it. But you know, when students come, you ask yourself, hey, there's no dislike in linear congruence part 2. No dislike at all as of now. Something that has more than 10,000 views. It has 57 likes, no dislike. And then linear congruence part 1, more than 45,000 views. 120 likes, 35 dislikes. 35 dislikes is too much, you know. So I said, you know what? Don't worry about it. Let me redo linear congruence part 1. And probably because I did it on an iPad, I don't know why. Well, I don't know whether it might be the reason I did the linear congruence part 1. I did it on an iPad. So, but that's by the way, so I am redoing it now, okay? Now, what is linear congruence? Let's say from our knowledge, like I said, please, it is recommended. All the videos before this video, this is a video playlist. It's a playlist, modular arithmetic and algorithms. It is a video playlist. All the videos prior to this particular one, it is highly recommended that you have viewed them. Then it is required that you have viewed the 2 videos of modular inverse part 1, modular inverse part 2. It is required because we are going to use something from there. So let's say this. When we have something like 8 mod 5, 8 mod 5 gives us 3, okay, right? 8 mod 5 gives us 3, the modulo operation. If you look at this here, we could say, okay, also, we could also say that 3 mod 5 is also 3. 3 mod 5 is also 3. So we could say from here, 8 mod 5 is equal to 3. We could say this implies, this means implies, this means implies. This implies that 8 is congruent to 3 in mod 5. It means that 8 is congruent to 3 in mod 5. What does this mean? Because this further implies that because we have 8 mod 5 to give us 3, and also 3 mod 5 gives us 3. So we say that 8 is congruent to 3 in mod 5. So 8 and 3 congruent mod 5. Congruent modulo 5. 8 is congruent. Or you can also say equivalent. These are equivalent classes because from here, from this congruence, we get to equivalence classes and the Chinese remainder theorem. This here is 8 is congruent to 3 in mod 5. And we say, I'm going to now define linear congruence, that 2 integers, say C and D. Let me use a yellow chalk. 2 integers say C and D are congruent modulo another integer. Congruent modulo another integer. say k. Two integers, say c and d, are congruent modulo. Congruent modulo another integer, say k. You can say they are congruent in that modulo. Okay, they are congruent modulo another integer, say k, if c mod k is the same as d mod k. If c mod k is equal to d mod k, which gives you another result. Okay? Or you can also say, or if c minus d, the difference between c and d is divisible by k. And that is congruence or equivalence or congruence. So two integers, say c and d, are congruent modulo k if c mod k is equal to d mod k. Or you can say if c minus d, the difference is divisible by k. So you see this example that I just did now. 8 mod 5 is 3. Also 3 mod 5 is 3. Therefore 8 is congruent to 3 in mod 5. See that? Then, or you can also say, that 8 minus 3 is divisible by 5. Is divisible by 5. Because in this case, our C is 8. Our D is 3. C and D. And then K is 5. Modulo is 5. See that? Because 8 minus 3 is 5 too. So 5 is divisible by 5. So because 5 is divisible by 5. Is divisible by 5. See that? Okay? So that's the way you do it. If C is congruent to D in mod 5. So when you have this here, 8 is congruent to 3 in mod 5, it means that 8 mod 5, whatever you get as 8 mod 5, and also whatever you get as 3 mod 5, they are the same. 8 mod 5 is 3, 3 mod 5 is 3. So C mod K is equal to D mod K. 3 is equal to 3. 3 is equal to 3. Okay? Now, but the easiest way, if you want to form, because this is our equality here, and this is our equivalence. Okay, this is equality, this is equivalence or congruence. The easiest way to go from one to another is by writing it like this. 8 mod 5 is equal to 3. this implies that 8 is congruent to 3 in mod 5. And you can do it, you can also say, it mustn't be, as you wrote it here, 8 is congruent to 3 mod 5. You can also say 3 is congruent to 8 in mod 5. You can also write it that way. Yeah, but I want you to be able, because we are still going to discuss more videos on this. We are still going to do more videos on this topic because it's very important. For this part 1, I would like you to be able to write it this way. You have the equality, just change it to equivalence right away. Okay, so 8 mod 5 is equal to 3. This implies, this is the equality. Okay, it's the equation. This implies that you now change it to equivalence. 8 is congruent to 3 in mod 5. And what does this mean actually? What does this 8 is congruent to 3 in mod 5? What does it mean actually? It means that 8 mod 5 is also equal to 3 in mod 5. And it gives you 3 because 3 is equal to 3. That's it. Does that make sense? Okay, let's do more problems. Let's do more examples, and then we are going to do problems. We are going to do questions. Another example. 12 mod 10 is 2. 12 mod 10 is 2. Right? So this implies that 12 is congruent to 2 in mod 10. You see, I put parentheses here because it means both of them. Okay? It means that 12 mod 10 is 2. 2 mod 10 is 2. Okay? See that? Or you can say that 12 minus 2 is divisible by 10. Is divisible by 10. That I want you to let it this way, for now, part 1. Just let it this way from equality to equivalence. How you write it right away. Let it this way for now. Another one, let's do negative number. If we have negative 8 mod 5, negative 8 mod 5, 5 into negative 8, negative 1, negative 5, minus, remember, negative 3. Okay, so you can have a negative remainder. You cannot. We did that in a video. That was, I think, modulo part 2. Modulo concept part 2. You cannot have a negative remainder. You can have a negative quotient, but not a negative remainder. Because you have here negative 1, remainder negative 3. Okay? 5 into negative 8 is negative 1. Okay, it gives you negative 5. Then negative 5, negative 3 is negative 8. But you cannot have negative 3. Because the remainder cannot be negative. Cannot. So, the next thing we do, we've tried negative 1. And we got a negative 3. Then the next thing we do negative 2. And do negative 2. So negative 2 remainder. So 5 times negative 2 is negative 10. Negative 10 plus 2 is negative 8. So that will be negative 2 remainder 2. So negative 8 mod 5 is just 2. Because remember the modulo is just the remainder. It's just the remainder. So negative 8 mod 5 is 2. So this implies that negative 8 is congruent to 2 in mod 5. And this further means here This further means that negative 8 mod 5 gives us 2. 2 mod 5 gives us 2. Okay? I know some people will be asking the other way around. Like I said, what I want you to learn now is going from equality to equivalence. That is what I want you to learn in this part 1. Okay, let's take this learning gradually. Let's not rush it. See, that's why I did all those videos. All those videos. If you do it step by step, this topic will be very easy for you. It's not difficult at all. It's not. But I want, I thank God for this talent, in me, the ability to teach so that people will understand. So when I saw those 120 likes, 35 dislikes, even though it's over 45,000 views, I said, let me do something else, and then I had several questions, because if you teach and students ask very few questions, that means, and they do well in the homework, that means they understood it. But when you teach, posting video, YouTube, and you have so many questions coming, you ask yourself, so rather than all those praises, which I appreciate, I appreciate praises, I thank God. So rather than all those praises, you say, how did you get this? How did you get this? How did you get this? So I said, I have to make this God's talent in me work well so that you learn it. So I said, no, I've got to do it again. Okay, so I hope, does this make sense? Do you understand what I'm doing so far? Do you see that? Let's do another example and then we solve problems. If we have negative 2 mod 9, okay, 9 into negative 2, that is 0, remember, that is, remember 7, okay, 7, that gives us 7, so this means that negative 2 is congruent to 7 in mod 9, meaning that negative 2 mod 9 is 7 and 7 mod 9 is 7. Okay? Now, these are all congruence, equivalence. Now, an important concept to note. We did modular inverse. That's the video I asked you to view before this one. When you multiply a number by the inverse, okay, let's say let's bring this to arithmetic. The inverse of 5 is 1 over 5. That is the multiplicative inverse of 5, 1 over 5. When you multiply 5 by 1 over 5, it gives you 1. One of the ways to solve equations, linear equations, is using the multiplicative inverse method. When you multiply a number by its multiplicative inverse, which is the same as the reciprocal, okay, it gives you 1. It gives you 1. The multiplicative inverse, the inverse of 1 over 5 is 5. When you multiply 1 over 5 by 5, it gives you 1. Now, bring that same concept here in modulo. We did modular inverse of an integer mod another integer. We did that in modular inverse videos, part 1 and part 2. We're going to apply that concept here, okay, when we're solving problems. So let's start with example 1. We have in linear congruence part 2, we did 2 problems. And in this video, we're going to do 2 problems. Because in modular inverse part 1, we did 2 problems. Modular inverse part 2, we did 2 problems. So modular inverse part 2, the problems we did there, we used it in linear congruence part 2. So we're going to use the two problems we did in modular inverse part 1. We're going to use it here. So in modular inverse part 1, we did this from part 1, modular inverse, part 1. Part 1. We found find the inverse of 4 mod 9. Okay, and we also found the inverse of 19 mod 141. So the inverse of 4 mod 9, we got negative 2 mod 9, negative 2 mod 9, which is 7. 7 mod 9, which is 7. We got this. In that video, that was what we got. Because we're going to use our knowledge, what we got from that video. So negative 2 mod 9 is 7 mod 9, and that gives us 7. 7 mod 9 is 7. 19 mod 141, we got it as 52. Okay, 52 mod 141, and that gives us 52. These are the inverse. Inverse of 4 mod 9, inverse of 19 mod 141. Okay, first question. Solve for the variable. Solve and check. Solve and check. Solve and check. Solve for the variable and then check your work. You know, Mr. C likes check all the time. Equations, inequalities, you gotta check. Now congruence, you gotta check too. So solve and check. Number 1, question 1, we have 4x is congruent to 37, all in mod 9. Mod 9. Solve and check. Find x and then check your work also. So you see this here, 4 right here and 9. So when you have a congruence problem, you look at the guy, because your aim is to isolate the variable. When you solve the equations in algebra or in inequality, you isolate the variable. The variable here is x. You want to make it by itself. So what are you going to, if this was the equation equal to, if this was the equation, you multiply both sides by 1 over 4. The multiplicative inverse. You multiply it by 1 over 4. If this was the equation, you did 1 over 4 times 4 times x equal to 1 over 4 times 37. That is, if this was the equation, that is what you would have done. So you can isolate x, and x will be 37 over 4. Okay, well, this is not an equation. This is a congruence, mod 9. So what you are going to do is you find the inverse of 4 mod 9. And we have already done it, so that we are not going to go back to doing what we've done before. We've already done it in this video, because that was the question students were asking me. Where did I get 52? It was in that video. So the inverse of 4 mod 9 is 7. So what we are going to do now is we will multiply both sides by 7. Okay, because when you multiply, when you have a congruence, if you want to isolate the variable, multiply it by the modular inverse. Multiply it by the modular inverse of the coefficient of that variable in the modulo. That's how you do it. The modular inverse of the coefficient of the variable in the modulo, which we did here, that the inverse of 4 mod 9 is 7. So we now multiply both sides by 7. Multiply both sides by 7. So this will be 7 times 4 times x is congruent to 7 times 37. All of them in mod 9. All of them in mod 9. That means, that's why I put parentheses, because this is all in mod 9. Remember, it's 4x in mod 9, whatever it gives us, 37 in mod 9, whatever it gives us. That's what we mean. So 7 times 4 times x. So we are going to do it step by step. We'll start with the left-hand side here. We'll start with the left-hand side here. 7 times 4 times x mod 9. Mod 9. So this is 28x mod 9. Now, this means 28 mod 9 times x mod 9 is still the same. When you have it, like this, that's what it means. This means 28 mod 9 times x mod 9 is the same thing. That's what it means. Okay? And if you want me, I can put parentheses there. That's what it means. Okay? So 28 mod 9 is 1. Because 9 times 3 is 27. Remember, it's 1. So this is 1 times x in mod 9. So this is x. X in mod 9. Okay? That's it. Still in mod 9. So just have x. So the aim is to isolate the variable. You have only x. That's the aim. The aim is to isolate the variable. So that's our left-hand side. Now we're going to do the right-hand side. Now we'll do the right-hand side. The right-hand side of the equivalence is 37 mod 9. Right? So, which is 9 to 37 is 4, 36, 1. And that is 1. Sorry, 7 times. I didn't even see 7. You should be looking at this one here. 7 times 37. So 7 times 37. 7 times 37. In mod 9. Okay? And this, this means 7 mod 9 times 37 mod 9. If you want to do it that way, it's still that way. If you want to do it that way, you can say 7 mod 9 times 37 mod 9. If you want to do it that way. And 7 mod 9 is 7 times 37 mod 9 is 1. Because 9 times 4 is 36. 37 minus 36 is 1. And this gives you 7. Still in mod 9. Okay? Still in mod 9. Which is 7 anyway. Which is 7. Because 7 mod 9 is 7. Or you can do it 7 times 37 7 times 7 is 49, 9, 4. 7 times 3, 21 plus 4, 25. Mod 9. To save time, you know, let's just, oh, I didn't even come with a calculator. Okay. Okay, I'm gonna go and get a calculator. Okay, I'm back. Just to save time, I mean, I can do it without calculator anyway, but you know I can do it without calculator. But it's just to save time in this video. It's just to save time in this video, that's all. So we have 259 divided by 9. 259 divided by 9 is 28.77777. Then you now do 9 times 28. 28 times 9. And that is 252. 252. And you now do 259 minus 252. And that gives you 7. Okay? So this is also 7. 7 mod 9. And that is 7. Okay, so as you can see here, we now have that x mod 9 is equal to 7 mod 9. X mod 9, left hand side is x mod 9. X mod 9, x mod 9 equal to 7 mod 9. So x is 7. X is equal to 7. Bam. That's the answer. That's it. You see how I split it? If you want to split it, that's fine. I mean, because I split it that way to show you the main aim of multiplying by the modular inverse is to isolate the variable. Alright, let's go ahead and check this now. When we check it, we check with the main equation. We check with the main equation. I'm using a simple calculator, okay? The main thing is calculator that works. Now we check with the main equation. So I'm going to come here. I'm going to erase this here. When we check with the, did I say main equation? Main equivalence. You know, when I teach equations, I always say, I always say that to my students, check with the main. Don't check with the modified equation, check with the main. Okay, here, check with the main congruence. So we have this, we have our left-hand side. Left-hand side is 4x. Mod 9, because this is mod 9. This means 4x mod 9. Let me write it here. What this means is that 4x mod 9 is equal to 37 mod 9. That is what it means. Remember when we wrote the definition, okay, the examples we give, that is what it means. 4x mod 9 is equal to 37 mod 9. That is what it means. So let's go ahead now and check it. Check. I check left hand side, right hand side. So our left hand side is 4x mod 9. And our right hand side is 37 mod 9. So our x is 7. Our x, as you can see here, is 7. So 4 times 7 mod 9, which is 28 mod 9, which is 1. Okay? And here, 37 mod 9 is 1. That's it. That's it. Do you understand now? Okay, so hope you understood it now. So you wouldn't want me to do another one by giving me the slides, right? If you don't understand, feel free to ask questions, please. You know, I like students to ask questions. So, because asking questions means, okay, do I need to teach it another way, or was there something I missed? Was there any step I missed? That's why when I teach a concept that is not normally user-friendly, I try not to skip any steps, you know. And I know some of you might be saying, oh, he's breaking it down so much. I've received that comment. Oh, he explained too much. Oh, he really broke it down. This video is long. I guess I cannot satisfy everybody, right? I cannot satisfy everyone, right? The main thing is for you to understand it, though. That's the main thing. So, if you still don't get it, just let me know. Okay, feel free to ask questions. Because if you ask questions, it makes me to at least to reflect, you know, to review it and see, okay, was there something I missed, or should I teach it another way? Because I have several ways I can teach. Several ways. All right, question 2, and then we can call it a night. Question 2 is solve and check. 19x is congruent to 4 mod 141. 19x is congruent to 4 in mod 141. So this means 19x mod 141 is equal to 4 in mod 141. That is what it means. 19x in mod 141 is equal to 4 in mod 141. That is what it means. That's the meaning. That's just the meaning. Alright, but first of all, before we solve this, we multiply both sides by what? We want to isolate x. We want to isolate x. So multiply both sides by the modular inverse. And in that video, modular inverse part 1, the inverse of 19 mod 141. Because you look at this coefficient of the variable, and then you look at the modular, inverse of this mod this. So this gives us 52. So multiply both sides by 52. So this means that 19 times 52 times 19 times x is congruent to, if you want to do it left hand side, right hand side, go for it. Okay? But, you know, I want you to be able to know how to do it right away, like that. Okay? So it's congruent to 52 times 4. All of them in mod 141. Okay. 52 times 19. This gives us 988. So 988x is congruent to 52 times 4 is 208. 208, all of them in mod 141. We now do 988 divided by 141 is 7.0007. We just take the integer part. 7 times 141 is 987. 988 minus 987 is 1. It's 1. Okay? Because this is, you know, this is like saying 988 mod 141 equal to 988x mod 141 equal to 208 mod 141. That is also like saying that. Okay? Let me put it. Mod 141 equal to 208 mod 141. Now this line again gives you now 1 times x. 1 times x mod 141 equal to 208 mod 141. 208 divided by 141 is 1.475 something. Just take 1. Just take 1. So 1 times 141 is 141. So 208 minus 141 is 67. This is 67 mod 141. So this is x mod 141 is 67 mod 141. So x is equal to 67. That's it. X is 67. And you must not do it this way, or even the way I did it the first time. Just do it the way you understand it. That's fine. Okay, but you know, I've done it this way so that it will make a lot of sense to you. So you don't give me dislike, right? So you don't give me dislike. So you like me. You like me. Okay, so let's go ahead and check this, and then we will call it a night. When you check with the main equivalence. Check with the main equivalence. So I'm just going to use this one. Right hand side, you like my video, okay? Anyway, you're supposed to like everybody. Yeah, you like me as a human being, then you like the video, not dislike. Okay. So left hand side is 19x. And 19x mod 141. Alright? And right hand side is 4 mod 141. So x is 67. So you do 19 times 67. Mod 141. Anyway, 4 mod 141 gives you 4 anyway. It gives you 4 right away. Then 19 times 67. 19 times 67 is 1273. So 1273 mod 141. 1273 divided by 141 is 9.028 something. Bring out the 9. 9 times 141 is 1269. Then you now do 1273 minus 1269. 4 gives you 4. That's it. Okay, so if you have any questions, please feel free to ask. I think it makes sense now. Okay, if you have any questions, please feel free to ask. Thank you so much for listening to this video. Please watch out for more videos on this topic. It's a lot. Okay, and like I said, this website has everything. That website. You can also go to my website as well. Thank you so much, and you have a good night.